Okay, so hello everybody. We are very happy to be here to talk about balancing privacy and utility when you work with textual data. First, a quick word about who we are. So Elisaveta and I, Justine, are both data scientists at HelloWork, which is the French leader in digital talent acquisition, so job search tech. And our mission is to connect either candidates and recruiters or students and training centers. In just some key figures, in 2024 it was 100 million connections. We are 600 people in the group, and we're a team of 7 data scientists. So first, let's give some context for the talk. Today we'll focus on personally identifiable information, or PII. So what is it exactly? Basically, it's any piece of information that can be linked to an identify or identifiable natural person, physical person. Of course, we usually think of names or addresses, but actually you have many information that can be considered PIIs, because when you combine them, you can identify someone's identity. And many documents that we process as a company or as a data scientist hold PIIs. You have invoices, you have medical records, and of course you have resumes where people tend to talk about themselves a lot. So why do we care about PIIs? Well, first, because we think that protecting people's privacy is just simply the right thing to do. And also increasingly, it's the required thing to do. Even if you're not big on ethics, you have legal frameworks like GDPR that mandate how you can process and store data that have personal information in them. And depending on the context, on how the data was collected, on what it's used for, etc., sometimes you may need to remove or anonymize the personal information. So today I'll stay clear of legal considerations. We'll be more focused on the practical takeaways, but when you need to share or to process documents with PIIs, sometimes anonymization is required. And you have 2 main strategies to do that. You can either do masking, which is deleting the info, like replace a name with a blank or whatever. Or you can do replacement, which is swapping the real data with synthetic but realistic information, like a number for a number or a name for a name. And when you do that, it's no longer linkable to the original person, but you keep a document that looks like a real document. So anonymization in itself isn't a new problem, and it's actually very mature for structured data, tabular data. You have plenty of tools out there to do that. Some are commercial, some are open source, but they can prove statistically that the data is well anonymized. They can do that in such a way that the utility is preserved, meaning that your numerical distribution is not all broken, for instance. But these solutions, they work mostly because the data is structured. You have columns, you have labels, you have tractable underlying distributions that you can use. And the challenge begins when you step into free text and PDF and images, unstructured data, because here the personal information can be anywhere, in any form. You don't know in advance. And besides, it's not even very well defined what text anonymization should be. So the traditional anonymization methods, they often fall short. And that's why today text anonymization is still a much harder problem. We have less tools. Validation is more complex. But because we work so much on textual data, we just couldn't say, oh, sorry, can't anonymize. Which brings us to the core of the presentation. Today we'll see how we can build a simple but efficient 2-step pipeline to anonymize text. And the rough outline is, first you detect where the personal information is, and then you find a good replacement for it. And we'll see that what's nice is that we can do that in Python with existing libraries and models. So now I leave Elisaveta to talk about the PII detection part.
Thank you, Justine. So to detect the personal information inside the resumes, we used the model called gliner, so generalist and lightweight model for named entity recognition. The name speaks for itself. It uses a bidirectional transformer encoder, like BERT, and it is a good compromise between traditional NER models and LLMs. Its advantage over traditional supervised models is that the labels can be added or modified on inference time, so without retraining. And compared to the LLMs, which are also very flexible with the labels, it is much lighter and so less resource intensive. Last but not least, the usage of the small models avoids sending the sensitive data to LLM providers. Gliner is very easy to use, as you can see on my example. So you load a model, you give a list of the labels of your choice and the text, and the model extracts the entities of these types in the text. And we also can get the position in the text and the score of probability score for each extraction. Several off-the-shelf models are available on Hugging Face, including Gliner Multi, which is a multilingual model. Most of our resumes are written in French, but some are in English, so a multilingual model will be perfect. And there is also another model already tailored for PII extraction, Gliner PII, but not specifically from the resumes. We tried these two models on our data. I will show you the numerical results shortly, but keep it brief. Some things worked well when others less. It is often the case in our work, especially when working with off-the-shelf models. So fortunately, there is a possibility to fine-tune them, so to adapt the model as best as possible to your data. By the way, yesterday you had a great talk here about the domain adaptation. And the model Gliner PII was obtained this way too. It was fine-tuned on the data, on the text containing fake personal data generated by Mistral. This approach inspired us to fine-tune Gliner on the fake resumes generated using an LLM. So to start, we asked an LLM to generate realistic resumes and at the same time to extract the personal data from them. We refined the prompt and we got a nice resume text for Sophie Martin in Paris, why not, with the accurately extracted entities. Perfect. We ran the query the second time and we got a nice resume for Sophie Martin in Paris. So, job title and address differ, but the text remain very similar. The third try, Sophie Martin in Paris. So it's starting to become problematic. We got this example with GPT-4o Mini, but we tried more powerful models, including GPT-5, and we arrived at the same conclusion. The names and the locations vary more, but the text remain very similar in their structure and formatting. It lacks variety. To address this issue, we decided to include a fake profile into the prompt, which contains the personal data we want to appear in the resume. And we vary it on each query, of course. And then we asked the LLM to create a resume for this profile. We generate the profiles using Faker, an open source library in Python, but it also exists in other programming languages. And it allows us to generate fake data of different types. And as you can see, we also specified a job title, generated by Faker2, by the way. It is not a part of the data we aim to extract or to anonymize, but it helps us to make the text more diverse. And this way, we generated high-quality fake resumes, and we control the personally identifiable information they contain. So we were satisfied, and the conclusion we can draw from this experiment is that with the LLMs, exactly as with the traditional models, the quality of the impact directly impacts the quality of the output. So today, LLMs are very impressive, but not magic. So we generated 800 fake resumes, which corresponds to 3,500 zones with labeled PII. We call zone a semantically homogeneous textual passage. Why not use an entire document, you might ask? The base model we use has a maximum sequence length parameter set to 384 words, and the real resume often exceeds this length. So we prefer to divide a document into meaningful passages and not to split at the middle of a sentence. But as you can notice, with this approach, we may have some zones with no entities to extract and to anonymize, like skills. It's normal. So it is possible to make fine-tuning on the data with an empty list of labels, but in this case, the model must be given an explicit list of labels, so during the training, it is able to form the negative pairs. You can still modify the labels later. And to illustrate this, I will take our use case. At first, we didn't add nationality in the list of PII to be anonymized. So it was not labeled in our fine-tuning data. But if we still want to hide or replace this information, we can do it afterwards, so we can add the label, and the model handles it pretty well, as you can see. It actually calculates an embedding for each label and the distance between the labels and the text spans. But be careful, the choice of the labels is crucial. A slight change in wordings can influence the results. So you need to try several sets of labels and several formulations to find the configuration, the best configurations for your data. And now I will present the results for our use case. We tried several models on 800 real resumes with manually labeled PII. The entities we want to extract correspond to the labels we use. You can see them in the headers of the columns. I only included the F-score here so as not to overwhelm you with the numbers. We started with the off-the-shelf models, gliner multi and multi-PII. To remind, the latter was has already been adapted to PII extraction, but not necessarily from the resumes, and not necessarily with the same labels. It performs much better than the generalist model for emails, for numbers, and birth dates. However, the results for locations are still poor, as you can see, and for the names, it's just disastrous. So we were surprised, and we looked at the data used for fine-tuning of the model, which is also available. And we saw that first name and last name labels are very rare in this data set, unlike the label person. Indeed, person is a very classic label in the task of NER, and it is present in all evaluation campaigns and all NER data sets. Similarly, in the fine-tuning dataset, the label address often covers the city and the postal code, which explains the poor results for these entity types. So let's see if fine-tuning on the resumes will help us to do better. We fine-tuned both models on the fake resumes. The model fine-tuned from gliner PII outperforms the others almost for all entity types. That's good news. That means that we can continue fine-tuning, customize the model for our data, and at the same time keep the benefits from previous learning. The bad news is that the results for the names still don't meet our expectations. To overcome this, we applied the latest model with the label person instead of first and last name. And we got much better score without affecting the detection of other entity types. I should point out that it's not just a matter of swapping the last name and the first name, but usually the previous configuration extracts nothing, where the last configuration extracts person. So clearly, we don't have enough data in our dataset to make the model forget this important label and learn something else instead. Whereas for locations, we managed to do it. The problem is that in our case, we need to distinguish between the first name and the last name because we determine the candidate's gender based on his first name. And we have chosen to keep the same gender when anonymizing the resume, primarily to ensure consistency with the text. As you know, French texts may contain gender markers. And the second reason why we need gender is to be able to check whether our other models, and such as job detection models, don't suffer by gender bias. So we retained the person label and added a binary classification step, just last name or first name, for tokens labeled as person by gliner. And now that we are able to detect the personally identifiable information in the text, we will replace them with the fake data. And I'm handing over to Justine, who will show you how we do this.
Thank you. So yeah, about replacement, we don't mean just random letters. We want to keep the semantic role of the data. So like we said, a name for a name, an email for an email, etc. For example, here on my slide, Jean-Philippe Delbos becomes John Doe, because we want to keep the dataset useful for another task. Let's say we have a use case where we want to create a dataset of anonymized resumes to be used as an evaluation dataset for other models that we have, like resume parsing or job title extraction models, for instance. So the good news is we don't need to do everything by hand. Once again, Faker can help us. But as you can see on the slide, sometimes the fake data is a little bit off, I'd say. It's not resembling actual resumes. Because we want to go one step beyond just keeping the semantic role. If we use this dataset for evaluation, we just can't have everybody named John Doe in the anonymized version. So we add a few constraints for a fake data generation. First, we will be modifying PDF in place. So we want the fake data to be of the same length as the original data, so that it doesn't break the layout. Also, we want to keep a good variety in casing, like for names we have lowercase, uppercase. Also diversity in addresses, for instance. We know we have roads, streets, we have abbreviations, it depends. And also, we want to keep the gender, like Elisabetta mentioned. We want the fake first name to be of the same gender as the original first name, so that it stays coherent throughout the text of the CV. So in the rest of the presentation, I'll go over 2 examples of data replacement, and we'll see how we can deal with the constraints. we'll start with first names, and we will build on Faker, but we will create a custom class, which we will initialize with a collection of names that are split by gender and length. You can initialize it with, for instance, Faker's built-in list, which is available in the library, or any list that you have, if you know your demographics. For instance, if you work on medical records, we know that the older we get, the more often we tend to go to the doctors, so maybe a list of older names would be a good idea, stuff like that. And then we create a Faker instance, and we use the dynamic provider class of the library, which is a Faker provider, so that's one of the building blocks of the library, which basically is capable of randomly selecting an element from a list. So of course we could do all that in pure Python, but using a Faker provider means that we get the same interface as the other ones, we get the same random algorithm, and also we get a bunch of functions already coded for us. And in a loop, we add one dynamic provider per gender and length couple. And in the end, to generate a fake first name for a specific gender and length, it's just the last line of code. Very, very simple. So that was the first example. And now about emails. So for emails, once again, length is important for us. And also, we want some control over the domain names, because we know that in resumes, we have lots of funkier email providers, like youruniversity.edu, stuff like that. And so this time we have a different approach. We actually extend the internet.provider class of Faker, which already has functions to generate emails, IP addresses, many things. But we will instantiate it with three things. First, the internet.provider default domains list. But as you can see, it's the pink rectangle. It's pretty short, very, very standard. So we also add the internet FR provider, which is the French variation of this internet provider, still inside Faker. But as you can see, the list is bigger, and you have stuff more typical for France, like wanadoo.fr. And also, we can give as argument a custom list of domain, which we will initialize with domains that we have collected in our production data, for instance. So this is a very basic implementation so that it fits on the slide. But actually, you can also add frequencies so that the proportions of gmail.com, clubinternet.fr, and audencia.com in the fake emails that you generate actually mimic the proportions that you find in real life, for instance. Then our second step is to override the function of internet.provider, which picks a domain address at random so that it uses our full list of domains. And then finally, third step, we create a custom function to get an email for a given length. And as you can see, it's pretty simple inside. We pick a domain, then we see how much length we have left for the first part of the email. And then we use another function of Faker, random elements, to create a combination of letters, digits. We also put in a couple hyphens and dots so that it looks like an email. So we have two pieces, we concatenate them with the @sign, and then we get a function that gives us an email that looks like a good CV email. So that was for the second example. So if we go back to our little resume, little header of resume, we see that the modified version now is a bit better looking. We can also work on formatting phone numbers, on formatting personal websites. In resumes, we have lots of LinkedIn or GitHub accounts, for instance. So we can customize all that and get fake resumes or modified resumes that look like real resumes. Okay, so in the end, what can you take home from all this? Well, first, anonymizing text is not as easy, as straightforward as anonymizing tables, but we're not doomed. We have seen that if we have clear priorities, if we know what it means to make the data non-sensitive, also what it means for us, for our use case, to keep a data set useful, then we can come up with an effective pipeline to do that. Of course, what we have shown today is just a starting point. We know there's room for improvement, but the goal was to give you like the basic ideas behind it. Also, another important point for us is don't underestimate the power of the open source Python and data science in general community. And about that, I wanted to say, don't hesitate to read the documentation, to look at the code in the GitHub repo, to look at how the pre-trained models are made and how you can tune them, because deeply understanding how the tools that you're going to use work will make you able to really unlock their full power. And also, don't hesitate to combine these tools, just like we did to generate the training data for Gliner. An LLM alone wasn't giving us the variety we needed for the data set, but using Faker only, it would have been really difficult to get full text of resumes that looked like good resumes. And it's using the two together that made it possible for us to create a data set that was good enough for training. So yeah, sometimes it's not about choosing a single tool among several options, but it's about how you can make them work together for a given task. Well, thank you. That's the end of our presentation. If we have a couple minutes left, we can try and answer some questions, and otherwise, thank you very much.
So first, I would like to apologize because I made a mistake when reading my watch, so we started much earlier than anticipated. So we have time for questions, and I can. So sorry for the people who joined late and missed the beginning. I can run over.
Thank you for your talk, very interesting. I had one question about the generation of email. I saw it was not consistent with first name, last name. Did you see, and usually when you create email address for your university, it's mostly first name, last name, university name. Did you see any out of distribution from the generated data compared to real world data?
Yes, indeed, you're right. That's actually something that we worked on in the full implementation that we did, and we also deal with the same thing for the LinkedIn account. Usually, your LinkedIn account has at least part of your name in it. So we try to make sure that not all of the fake emails or fake LinkedIn accounts were like that, but some of them, a good proportion of them, were coherent with the first name. So it's really like replacing the data step by step so that you have a whole coherent CV, yeah.
Thanks a lot for the talk. I was just wondering, looking at the scores, it's not perfect. And of course, you can never expect that from a model. How do you deal with that in practice? Do you mainly annotate it now, mainly replace it? I'm really curious.
Yes, thank you for your question. Of course, it's not perfect, and we can perfect it, but it depends of the task. And with anonymization task, it's a global task. So to anonymize a person, it consists of anonymization of first name, last name, street address, and all these entities. And so if the model fails on detecting first name, for example, but we managed to replace all the others. It's not the same person. And the same way, if the street address is not replaced, but the city is replaced, the postal code, all the names. So we see it globally. So of course we can do better, but it's the first step for to anonymize the resumes. And also, I can add that there are different types of errors too. Sometimes it's just inversion of first name and last name. Okay, for other usage, it's a mistake, but to anonymize, it's not so important. The important thing is to hide this information.
So, I had a question regarding so it's not enough to labelize each piece of text, what type of text it is. I guess you have to also regroup pieces of the resume together. I don't know if you can talk a little bit about if it's okay, if it's part of the scope of the talk, about how you could do that.
I'm not sure I understand the question. Sorry, you mean like have, instead of looking at individual words, like looking at paragraphs or different zones?
So for example, if you want to, so in a resume, you would get, for example, the name of the person, each professional experience, things like that. And I guess you would have, in addition to labeling each piece of text, which type of text it is, you would have, for example, to be able to split the experience, to be able to distinguish, for example, that one professional experience is related to this job experience or something like that. I don't know.
Okay, so yeah, indeed, when you analyze like a full resume, but I guess that would be more for a production setting, for like you have a resume parser to plug into your HR software that analyzes candidates for a given job position, for instance. Indeed, usually one interesting approach is to try to find the different pieces, the different, what we call zones of the resumes that are coherent and gives us information about the education of the person, its for her professional experiences, his contacts, etc. So yeah, that's when you parse a resume, usually you have several steps that you go through. First, you look at the whole layout, find the different pieces, and then each pieces you try to find, like for one experience, the dates, the company, the job title, the skills that the person developed during this experience, etc. So yeah, that's a good pipeline. But you don't need to do all that for the anonymization part, or at least for the basic anonymization that were presented, because if you are just interested in contacts like names, addresses, emails, you don't need to understand the whole education and experience part. I don't know if that answers the question or not, but.
Hi again, I have another question. In the pipeline you just described, often it starts with OCR or something like this. Are you dealing with PDF or are you dealing with forms or PDF? So in the data, did you add some OCR artifact for the training? Okay.
So yeah, indeed, the resumes, they come in many different forms. We have a vast majority of PDF, but we also have PDFs that are actually false. PDF is just one image stuck in a PDF file. We have Word documents. We even have candidates that use like text files or weird files that you wouldn't expect as a resume. So you have, what we didn't talk about is the first step to try and come back to either a PDF or also use an OCR step. The OCR step or a vision step can help us also understand the layout for more complicated resumes that that don't translate good into PDFs. Yeah.
Any more questions? I have one otherwise. So thank you again for the very interesting presentation. I'm wondering, when you generate such synthetic data, do you run the risk of introducing subtle biases? For instance, if you generate names with a bias toward Western names and hide some maybe problems by doing that?
Yes, very, very good question. We thought about it. We didn't analyze the proportions of the names, etc. But this is one of the reasons why we used a faker for this step, to be able to control distribution of, it can be geographical distribution too, gender distribution. We didn't make this statistics for the moment, but at a glance, it was okay. It was much more diverse than with an LLM approach.
Okay, thank you. And when you used LLMs to generate training data, you only use them for generating the training data for the recognizer, or also for imputation of fake data? And if so, do you run the risk of leaking private personal identifiable information that is built in the LLM down to your synthetic dataset?
Yes, we care about privacy. This is why we don't send the resumes of our candidates to LLM providers without agreement, of course. So for this experiment, we didn't send any personal data, so we used only the fake resumes. We sent only the fake resumes to LLM.
Okay. So if there are no other questions, one more. Still have a couple of minutes.
Thanks. The question I had was, from a, say, a legal or a GDPR perspective, is there a notion of like an accredited PII detection algorithm, like a certain performance it has to satisfy in order for it to be meeting those policy or legal requirements? Or is that just a silly question? I'm not sure.
I'm sorry, I really didn't understand. And here, I didn't hear.
Oh, sorry.
Go ahead.
So the GDPR requires personal information to be removed from certain documents, but does it specify what level of say, performance, like accuracy or sensitivity? Like, is there a certain benchmark you have to have exceeded?
Well, to our knowledge, it's not very well defined what is expected in terms of anonymization for text data. I mean, it's pretty clear for like when you have tabular data, if you have a column that has names or IP address or emails, that you need to anonymize that. I mean, once again, depending on how the data was collected and what's the consent and how do you store it, how do you use it. But for text data, it's not as clear because like text, it's not just one single piece of information, it's like a whole, and you can have many different information in a paragraph or a sentence. We talked with different companies that work on anonymization tools, and what I understand is that so far we're trying to come up with good definition of what should we do, and then when we have a clearer view of what should we do, then how can we actually do it? So that's where we stand at, I'd say, right now.
Okay, I think we can thank the presenters and then have a break. Thank you.